Hello and welcome to SystemVerilog in 5 minutes. Today we'll look into some concurrent assertion examples. This assertion is checking if a variable is a constant one. If this is the behavior of the variable, the assertion would pass here, and it would fail here and here. Now if the variable is synchronous to the clock, at this point the assertion checks the value prior to the clock, and therefore it passes. Now an interesting case is when the variable has a glitch in between the clock. In this case, the assertion would pass at all clocks. So here are two conclusions. Firstly, using property to check a constant is overkill. If the variable is truly constant, checking it at all clocks is a waste of time. Secondly, a variable in property should be synchronous to a clock. Else, the clock would need to be at a high frequency so that it can sample all changes in the variable. This example is almost the same. It checks two variables A and B. A and B are 0 and 0 here, and it fails. 1, 0 and it fails. 1, 1 and it passes. And 0, 0 and it fails. This example is called overlapped implication, but never mind the name. Generally, this part is treated as a condition and this part is treated as an expectation. Analyzing the same wave, at this point A is 0 and therefore B is ignored. The assertion is considered vacuous. It neither passes nor fails. At this point A is 1 and therefore B is checked. B is 0 and it fails. At this point A is 1 and then B is checked to be 1 and it passes. This point here is another vacuous attempt. This example is called a non-overlapped implication. It is similar to the one before except that it checks B on the next clock. This is a vacuous attempt. Here A is 1 and B is checked on the next clock. It is also 1 and therefore it passes. Note that while B is being checked at this clock, another assertion is starting at the same time, where A is 1, but for this one B is 0 on the next clock and therefore it fails. This point here is another vacuous attempt. This example is similar to the one before. The double hash is used for delay, where it indicates number of clocks. Here it means check A equals 1, and 1 clock later check B equals 1. However, unlike implication, this part is not a condition. If A is not 1, the property fails. Generally, double hash is not used like this because the assertion can only pass if A and B are 1 pretty much at all time. This example is to show its behavior in the simplest manner. This example shows a common usage of double hash along with overlapped implication. It means if A is 1, then check B is 1 after 1 clock. It is exactly the same as a non-overlapped implication. However, this format is better because you can now use different value as delay. Let's say the delay is 3. Looking at this wave, all the points here A is 0, therefore these are vacuous attempts. At this point where A is 1, it will check for B is 1 3 clocks later. Now it fails because B is 0. If there is a B pulse here, the assertion will still fail unless B is 1 here. If B is delayed further, it would fail as well. Now writing assertion is a delicate matter. Let's say this is the behavior we want to check. We need to make sure the property can catch any unexpected behavior. Let's say A and B are unexpectedly 1 at all times. This assertion would always pass, giving us a false positive that the expected behavior is achieved. If we truly want to check the behavior before, we want to write the condition this way, where A changes from 0 to 1. At least if A is 1 at all times, all assertion attempts will be vacuous. Now if A is a 1-bit variable, you can use rows to indicate such transition. If we use the wave before, here A changes from 0 to 1, therefore it checks if B is 1 3 clocks later. Similarly, if you want to check if B transition to 1, you should use rows here. You can also introduce a range in the delay. Here B can rise to 1 3 to 5 clocks later. Therefore this behavior would pass, this one too, and this one. If B rises at any other time, the assertion would fail. Now here's a quiz. A rises here and B rises 5 clocks later, which is expected. Say A rises again here, but there is no new B rising. Would this fail? The answer is no, because B rises 3 clocks later from here, which matches the property coding. And now before I go, there are still many areas that I didn't cover. For example, they are fail and stable. But I hope this would give you sufficient foundation on writing concurrent assertions. Next, we'll look into cross-module reference.